Using integration, find the position of the center of the mass of a uniform solid cone. So you need to once again find the solid cone. Like even in 2012 it was the cone, and even once again in 2015 it's the cone. Like so, they might repeatedly give you to find these things. Right? Like therefore, and the uniform solid hemisphere of radius simple. Right? So you have to find two integrations here. Right? So like with the years, like they have included two integrations, right? So can't help, you'll have to, so somehow like if you waste a lot of time to do the first part, so you will not have time to do the rest of the thing. Like you have to time just exactly 25 minutes for one whole question, right? So that is how you should do. Yeah, of course, like, since I have to teach it, it takes a lot of time, but still you need to do it quickly as soon as possible. Right? They're saying R, let R denote the solid solid body obtained by removing a right circular cone C of base radius A and height A from a solid hemisphere of mass capital M, radius A and center O. Find the mass of the solid body R in terms of capital M and the position of the center of mass. First of all, do they say let R be the solid obtained by removing a right circular cone, right? Okay, so this is it. So first of all, this is the question, right? So 2015, 16th one. In the very beginning, they are asking the center of gravity and the position of its center of mass. Find the mass of the solid. Yes. I will find the center of gravity from here onwards. Right? Yes, it's going to be easy. From this, from a solid cone, right? From a solid cone, from a solid hemisphere, a solid cone is removed. From the solid hemisphere, a solid cone is removed. So what's remaining is this. So this is C. Sorry, this is R. This is R. You need to understand that. This R. Straight away, they have not asked us to find the composite object that they have shown in the diagram, right? So that we will have to find somehow, but still initially what they have asked is this. So let's apply our usual object mass thing, and let's see object mass COG from origin. What is the object? First object is a hemisphere. What is the mass of the hemisphere? Rho rho 2/3 phi. What is the radius? Radius is A. Radius is A. Phi A cube. Rho 2/3 phi A cube. Right. So where is the center of gravity? So it's at 3A over 8. So if it is a cone, if it is a hemisphere, we know the center of gravity is going to be at 3A over 8. Center of gravity is going to be 3A over 8. Right? So yes, that's fine. All right. And then once again, from this cone, sorry, not cone. from this hemisphere, from the solid hemisphere, a part of cone is removed, right? So you need to think about this in 3D manner. So there is a cone, sorry, a hemisphere. From that hemisphere, a cone is removed, right? So the removed cone, this. So rho, what's the volume? 1/3 pi. Radius is a squared. Once again, height is also what? Height is also a into a, which means a cube, right? A cube. 1/3 pi a squared into a. So from the base, the distance to the center of gravity of the cone is a over 4, h over 4, right? So if this is h over 4. So I'm not going to tell you how these things came, right? So like you should be somewhat fluent in these things, because like it's 2 is to, so 3 is to 1. 3 is to 1, it divides, right? So, and then like also in the above question, they have asked you to prove it, right? So by using integration, so therefore, yes, it will be a over 4 from the below. So now the composite. What is this? From this you need to subtract this. So from 2 phi a cube rho over 3, you need to subtract phi a cube rho over 3. So therefore, when you subtract this from this, you're going to get, once again, rho phi a cube over 3. So from this, if you subtract this, also here it's 2, here 1, 2 minus 1, 1. So where is the center of gravity? I don't know. It's bar. It's bar. Right? So let us find the what? Find the center of gravity. So it's very easy. This into this. Sorry. So how do you get this? From this, you need to subtract this. Then you get this. So this product minus this product gives you this product. So go into 2/3 pi a cube to 3 over a over a. Go into 2/3 pi a cube 3 a over 8. See this minus this minus this. Oh, 1/3 pi a cube into a over 4 is equal to this product. So pi a cube over 3 into x bar, right? Simplification. I think let's avoid the simplification. The question is, yeah, it's fine. It's okay. It won't take much time, right? So I'll quickly simplify. Go. 5 to 5 to 5 a cube to a cube. So this 3 to 3 cancels, right? So 2 over 8 cancels 4, right? So a over 4 minus a over 12 x bar over 3, right? So 3a minus a is equal to 12 is equal to x bar over 3, right? So I will cancel this 4. So 2a over 4 is equal to x bar. X bar is equal to a over 2. X bar is equal to a over 2. H bar is equal to AO2. Right? Yes. So in R, the center of mass is AO2. From where? From the center. So let's say once again, the solid cone C is next fixed to the solid body R. The solid cone C once again is fixed to the solid body R. So what is R? This is R. For R, the removed solid cone is fixed as shown in the figure. The circular edge of the base is rigidly attached to the rim of the circular edge. The circular edge of the solid base of C is rigidly attached at ring R, so that the center of the ring R, the center of the ring is coincide the center of the base of C. So you can say there. The solid cone C. Yes, this solid, no, not this, right circular cone C, removing R. The removed part is C. Yes, the circular cone R, the solid cone C is next fixed to the body R, so as to form composite body S. Composite body is S, as shown in the figure. The circular edge of the base C. Okay. So of the cone. So circular edge of the cone. Circular edge of the C is rigidly attached to the rim of R, right? Okay. So that the center of the so that the center of gravity of the body S is at a distance from the common center of this. Once again, so the question is done from here. Once again, you have to go from here, right? Right. So we'll draw the figure here. So what is the figure? The figure is, it's going to be like this. Like we need to find the center of gravity from where? From where? From the base, common interface, which means I will take this as this. Right? Very easy. Right? So this is a mass. This is a mass. This mass. This mass. So I'll continue from here. So yes. Now you know x bar. X bar is what? X bar is A over 2. X bar is A over 2. But for the new section, for the new system, I'll draw once again. Right? What is the mass? So from where is the center of gravity? From the origin, from this origin, where is the center of gravity? Somewhere here. Minus A over 2. Minus A over 2. It's in the minus side, right? So it's going to be minus A over 2. Right? And this is what? This is a cone. This is this cone. Exactly this cone. This cone. This cone. Right? What is the mass? Mass is this. So from the base, at what distance? A over 4. So what is the combined object? this. So this plus this mass, you need to add. When you add these two, you are going to get this, right? When you add these two, you definitely should get this, right? From this, when you subtract, you got this, which means when you add these two, once again you need to get this. The same thing. Right? Center of gravity, I don't know. X y bar, x naught bar, somewhere x naught bar, right? X naught bar, x naught bar. So you'll be getting this how? You're going to get this how? By adding these two, you're going to get this. By combining these two, you're going to get this, which means you need to add these two products to this. These two products, when multiplied, will give you this product. Right? Okay. Right. Let's multiply the two products. Rho phi a cube 3 minus a over 2 plus this product. Rho 1/3 phi a cube a over 4. It's going to give you this product. 2 phi a cube rho over 3 x naught bar. Right? X naught bar. Let's simplify. 3 to 3 to 3 cancel. This 2, this 2, this cancels. So minus a over 2 plus a over 4 a over 4, right? 2 x naught bar, 2 x naught bar. Right? To simplify this, minus 2a plus a over 4 is equal to 2x naught bar. It's going to be minus a over 4, 2x bar. X naught bar is equal to minus a over 3. This is the answer that they asked, right? This is the answer that they asked. That is a over 8 from the common base. So it's not towards this side, it's towards this side. So x, like, why did we get minus here? This minus denotes that. This minus denotes that the like I took this as, I took x naught bar to be in this side, but in the answer I got minus. That denotes x bar is here. Of the composite object, center of gravity is in the minus direction, right? So it's fine, and we got the answer. It's going to be there, a over 8 from the center, from this center, from this common base, a over 8, right? Okay, so yes, that is it. And then the rest is obviously going to be equilibrium, right? So equilibrium, you can try it. Like they have told the composite body is freely suspended from point P of the edge, point P. So where is point P? They have given the point P. This is point P. So the center of gravity is somewhere here. So it's going to hang how? So try this, right? I will draw you the. It's going to hang like this. it's going to hang something like this, right? So where is the center of gravity? So it's going to go like this. Weight is W, right? So this is point P. This is point P, right? Yes, find the inclination of the axis to the horizontal. So this is the axis of symmetry. Inclination of the axis of symmetry to the horizontal. They are asking this. This is theta. This is 90 minus theta. This is 90. This is theta. This is theta, right? So what is this? This is the x bar. A over 8. So what is this? 8. Radius is 8. So tan theta, you can apply tan theta, right? You can apply tan theta and with the theta. So, and then the rest of the questions, yes. What is the mass that you should place on this edge of the vertex so that this comes? What is the mass that should be placed? M1, M1G. Weight, W, tension. So get a moment around P. If you need to find M1, get a moment around P. Around P, get a moment. So W in this direction, N in that direction. You are going to get M1. Right? So it's going to be pretty much easy, right? So, and then the rest of that is also kind of easy, the B part, right? So, yes. Yeah, it's also not that hard. So, you can try it on your own, right?